I hope all of you are alive. I hope all of you are alive.
Yes, sir.
Should we start?
Yes, sir.
Yes, sir.
Yes,
See,
sir.
where I left yesterday, I will start from there. The most important part in the confirmatory factor analysis and SCM is the reliability and validity test. The reliability and validity test. Have you all downloaded? If you have all downloaded,
Yes, sir.
then look at it. Yes, somebody is asking something.
No,
Okay.
sir.
If you have all downloaded, look at my screen. Such like Excel sheet will be there, and this is what the old Excel sheet, Gaskin's old Excel sheet I have in my computer. So I will first operate in the old Excel sheet, then I will operate in the new Excel sheet. Do not worry. Why I am operating in the old Excel sheet? Whatever calculation I have made yesterday, these are all available in the old Excel sheet, and some advanced properties are there in the new Excel sheet that you all have. Both the old Excel sheet and new Excel sheet I have sent to the organizer, and they will send to you. Barada sir, have you all sent these files?
Sir, I have given these two files in the WhatsApp group. They can download.
If you can send
Yes,
to
sir.
their
We got
email
it.
ID.
I'm doing, sir. I'm just sharing that in the chat box.
To their all email ID, else you can send there, or they can download it.
Okay,
These
okay.
are all free. These are all free from the start week. Do not worry. Okay. So if anybody has the Excel sheet, such like Excel sheet will be seen to everybody. Everybody
Sir,
is able to
excuse
see
me,
my.
sir.
Yes.
In your sheet it was written A1 and F1, but whatever we downloaded in our sheet it is written A2 and F2. Is there any problem, sir? I think there should not be any problem. Paste
No.
correlations table.
Please first listen me. There are so many options below the Excel sheet. Go to the validity master.
Yes, sir. Validity master only I opened, sir.
So
there
I can see
there
it, I can see it is A1. What is the wrong with it? Okay, let me open the new Excel sheet also. Let me open the new Excel sheet also. Whether it is written A2 or not, I do not know. Okay, let me open the new Excel sheet also.
Okay, sir.
If it is written A2, then there is no problem at all. You can go ahead with A2. You can go ahead by A2. Hold on for 1 second. My new Excel sheet I am opening. Whether it is written A2. It is written A2. Yes. There is no problem. There is no problem with A2. No problem.
Okay, sir.
Clear, sir, now? Clear, sir,
yes,
now?
Sir.
May I know your name?
Clear, sir. Clear. Bapan, sir.
Bapan.
Yes, sir. Yes, sir.
Okay. All of you able to see my Excel sheet? Are somebody should say yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
I'm going to the analysis that I have already made yesterday. So this is what the analysis. Let me go to the ASBM workshop. The same thing. I have already made the second order factor analysis, but in order to do the reliability validity test, I need to remain in the first order and I need to make the covariance. So I will go to the interaction model. So this is in the first order level and all the latent variables are covariated. All the latent variables are covariated. In order to test the reliability and validity, the latent variables need to be covariated. All of you are listening. My screen is visible clearly and my voice is audible clearly.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So in order to test the reliability and validity, you need to remain in first order and you need to covariate everything as it has been done. Now I will operate. I will attach the file. I will make my SPSS file available for AMOS. The same procedure. Go to the file, locate your file, then click open, then click OK. Now my AMOS has been incorporated with the file. Now the same process, I will go to the analysis property. Whatever I require, I will make it checked or ticked. I have already ticked today. So these are all remaining here. So then I will close it. Then I will calculate estimate here. Please look at my cursor movement. I can calculate here. Else I can go to the analyze property, then calculate the estimate. Now the estimation process is going on. You can see in the right hand side there is a box. The estimation process is over and the right hand side box is also closed. Now see, the upward red highlighted arrow mark has been highlighted. So in order to see immediately the values, you can click here. You can click here. Now values are appearing, but by default these values are unstandardized. So in order to get the standardized, you need to click in the left hand side standardized estimates. You need to click in the left hand side standardized estimates. Now you got everything. For reliability and validity, I need to go to the test output. Again, for the test output, there are two options. Look at my cursor movement. There is an option in the left hand side. You can see, you can put your cursor there. It is visible that view text. You can click there, or you can go to the view option, view menu, or you can go to the view menu in the above and click there, and it is written text output. The same option, text output. Click there. So there are two options to go to the text output. So I have clicked there. Now my text output are open. What I need to do, I need to go to the estimate. There is a option, there is a menu in the left hand side, estimate. Please go there to the estimates. There is a menu in the left hand side, estimate. There are so many menus, starting from analysis summary, notes of group, variable summary, parameter summary, sample movement, notes of the model, then estimate, then modification indices. So many things are there. So go to the estimate, all of you. Are you all following me?
Yes,
Anyone
yes,
can
sir.
answer?
Yes, sir. Thank you.
Yes,
Okay,
sir.
go to the estimation. Such like estimation figure will appear. Our duty lies as two things. One is standardized regression weight. So make a left click, then make right click, then copy. Make left click, then make right click, then copy. Go to the file, go to the SPSS file. I am doing in the old SPSS file first.
Excel file, sir. Excel file.
I am doing in the old SPSS file first in order to show you all the calculation that I have made yesterday.
Sir,
tell me.
In SPSS or
No.
Sir, I am saying
there is nothing to be done in SPSS. None. The Excel file, the Gatwick Excel file.
Sir, I am doing everything in Excel file. I am repeatedly saying Excel. You are asking SPSS, Excel. So please see my screen fast, then you will do. I am doing very slowly. So I have copied, again I am saying, look at here. Make a left click in the standardized regression weight of the output screen. Then make a right click, then copy. Then go to the Excel sheet. I am doing in the old Excel file. I am copying here now. I'm copying here. Sorry, I'm pasting here now. I have pasted it. Look at here, I have pasted it. Nothing to do, only paste it. Do not make any edit. I am repeatedly saying do not make any edit, because macro has already enabled. James Gaskin has made it very handy to calculate. Nothing to do, only to paste, then click, nothing else. Now paste it.
Sir, we can paste anywhere.
Sir, first listen.
Excuse me,
Bapan
sir.
sir. Bapan
No,
sir,
at
please listen
F1.
first. Sir, listen first. Listen. Now, first job is over. Now go to the second job. Go to the output file of AMOS. Then go to the correlation table. Go to the output file of AMOS. Go to the correlation table. Make left click. Then right click. Then copy. Then paste in the A1. Paste in the A1. I have pasted it. Now see the magic. Now it is written click me. Click me. That means exactly on that portion click. Now see the magic. Now see, output has shown to you. All of you able to see my output? All of you able to see my output?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
So there was some technical problem in my laptop yesterday, so I was unable to do. Now that technical problem I have solved. Now you see the magic. All the thing you have calculated yesterday, AVE, now is coming. Look at here. AVE for first construct. First construct was comprehension. Look at her. Second construct is credibility. Third construct is convenience. Fourth construct is compatibility. Fifth construct is caring. Look at these constructs in the left hand side of the Excel sheet. In the left hand side of the Excel sheet. So now look at here the AVE value for the first construct. I am saying construct, not indicator. Construct. These are all construct. Look at here. Look at the AMOS file. Credibility, convenience, comprehension, caring, compatibility. These are all 5 constructs. So these 5 constructs are appearing here in the Excel sheet. In the Excel sheet left hand side, please see. Now one by one you see, for the comprehension, AVE is 0.569. For the credibility, AVE is 0.588. For the convenience, AVE is 0.581. For the compatibility, AVE is 0.581. For the caring, AVE is 0.617. That means all the AVE values are above 0.5. One criteria of convergent validity is proven. One of the criteria of convergent validity is proven. One of the criteria of convergent validity is the average variance extracted must be more than 0.5. You see, all the values of average variance extracted are more than 0.5. Now, if any particular AVE will be less than 0.5, this macro file James Gaskin has made in such a manner that it will be red highlighted automatically. So you can detect very easily. And in the below, like it is written, wow, it will be written some caution or warning. If by chance any AVE value for anybody's research will be less than 0.5, like it is written in the below, wow, it will be written a caution or warning, and that warning will be red, and here the AVE will be red, which will be less than 0.5. As because our all AVE values are more, there is no red highlighted. Wow means everything is okay. Now this up to this AVE, if anybody has any doubt, you can ask. Bapan, you can ask now. Bapan, you can ask now.
No, sir. I'll ask her later on.
No, you can ask now. One by one, I will go. Huh? You can ask now. Okay. Anybody else? Anybody else? Okay. Should I move ahead?
Yeah, it is clear, sir. It is clear.
Okay. Now go to the next thing. Look at here. Go to the next thing. Look at here. What is that? Next criteria of convergent validity. It is one criteria of convergent validity. Next criteria of convergent validity is CR. CR means composite reliability. CR means composite reliability. I have already shown you the formula for the CR. I have already shown you the formula for the CR, and you have already calculated for one construct. Whatever calculation you have made yesterday, that calculation for one construct only. Now, this macro Excel sheet has been prepared in such a manner that James Gaskin has made it very handy.
Excuse me, sir.
Tell me.
Sir, I could not get the answer, sir. I was trying, that's why I did not ask you anything, sir. I was trying, but I did not get the answer. So, could you please repeat the process again, sir? Last process, sir.
Which process?
This copy paste and then clicking.
So that is the reason I was asking you, and I was saying, okay. Now
No, sir,
this file is visible. Now you ask the question, listen carefully. Listen carefully, all of you. All of you are there in this Excel sheet?
Yes, sir.
Bapan, you say yes or no?
Yes, sir.
Go to the output file of AMOS. Go to the output file of AMOS.
Yes, sir.
Go to the standardized regression weight.
Yes, sir.
Look at my screen.
Click. Okay, sir.
Then copy.
Yes, sir.
Done. Then go to the then go to the F1. Done. Then paste.
But sir, F1 is not seen in your this thing, sir.
Arey, sir, F1. Look at here, F. This is F and this is 1.
Okay, sir.
Look at here.
Sir. Okay, sir. Copy, then F1. Yes, sir. Then paste, sir. Done, sir.
I have already made a mistake by telling about you. F1 is not written. You need to count F and 1. F of column, 1 of row.
Yeah, cell. Yeah, cell. F1 cell.
See, you are not listening carefully, and you are asking. Again, I need to open. F1 is not written in the old file. You need to go to the F column, 1 row.
Yes, sir.
Now I have pasted it. I'm sorry. Again, I need to copy it. Copy. Paste it. Done or not?
Yes, sir. Done. Sir.
Then go to the correlation table. Correlation table.
Yes, sir.
Correlation table of AMOS output. Then copy.
Sir, then copy it.
Then paste it on A1.
Yes, sir.
Done. Are done or not?
Sir.
Yes or not?
Yes, sir.
Then
done, sir.
Come to the right hand side. Click me.
Yes,
click
sir.
me. Done.
Yes, sir.
See what I was saying. The second criteria of
sir.
convergent validity.
Yes, sir. Sir, okay, sir. Let me click it.
Bapan sir.
Sir.
Yes, sir. You can.
Sir, I think.
Bapan sir, listen me first. If you unable to do it, understand the process which you can practice later on. Do not worry.
Yes, sir.
See, all of you please look at here. I am doing in the old Excel macro sheet. Okay. Now going to the CR values. CR value is second criteria of validity. The standard rule is the composite reliability, which is CR, should be more than 0.7, and all the values of CR are more than 0.8. That means obviously it is a more than 0.7. All the values of CR, look at here, CR means composite reliability. CR for comprehension is 0.841, CR for credibility 0.877, CR for convenience 0.874, CR for compatibility 0.847, CR for caring 0.865. So all the values of CR are much above 0.7. Composite values, composite reliability values for every construct are much above the standard value, that is 0.7. So the second criteria of convergent validity is also proven. Both of the criteria of convergent validity is proven. All of you clear? All of you clear now? Any doubt till now? Any doubt? No. So now come to the discriminant validity. What I said discriminant validity? Discriminant validity is how strongly, how satisfactorily, or how significantly the indicators, yani ki exogenous variables, yani ki independent variables, are discriminating any construct from the rest of the construct. In our example, F1 having 5 indicators. So how significantly those 5 indicators are discriminating one construct from rest of the constructs of your study, one construct from the rest of the constructs of your study. For that, there are so many criteria. One of the criteria is both the MSB values and ASB values must be less than ABE. Look at my screen. Look at my screen. These are all MSB values. Look at my screen. These are all MSB values. MSB means maximum shared variance. Maximum shared variance. Look at here. All the MSB values are less than ABE values. Look at here. MSB value of comprehension is 0.311. All of you please look at my screen. MSB value of comprehension is 0.311, which is less than the respective ABE, that is 0.569. MSB value of credibility is 0.282, which is less than the respective ABE value 0.588. MSB value of convenience is 0.311, which is less than the respective ABE 0.581. MSB value of compatibility is 0.311, which is less than the respective ABE value is 0.581. MSB value of caring is 0.291, which is less than the respective ABE value 0.617. So all the MSB values are less than their respective ABE values. All the MSB values are less than their respective ABE values. And all the ASB values, ASB means average shared variance. Also, all the ASB values are less than, look at my screen, all the ASB values are less than their respective ABE values also. See, look at ASB value of comprehension is 0.289, which is less than the respective ABE value, also less than the MSB values. Also less than the MSB values. Look at here. See, two things you need to simultaneously see. Average shared variance must be less than the MSB and less than ABE. That is the reason I have explained first MSB. That is the reason I have explained for MSB. Now I am explaining ASB. ASB means average shared variance. average shared variance must be less than the respective MSB values plus must be less than from the respective ABE value. This is one of the criteria of discriminant validity. So one of the criteria of discriminant validity is proven. All of you are clear? All of you are clear? Anybody can say answer yes or no?
Yes, sir.
Okay.
Yes,
Okay. Now second criteria. Second criteria is the off diagonal values must be less than the diagonal values. Look at here. This is the correlation matrix, covariance matrix. Look at here. Look at here. This is the covariance matrix. I have highlighted in the Excel sheet. This is the covariance matrix, or you can say correlation matrix. I have highlighted in my Excel sheet. All the off diagonal values must be less than diagonal values. That means the interconstruct correlationship must be less than their respective covariance. Their respective covariance. Now look at the standard. Let me go to the PPT so that I can show you and you can understand it better. So that I can show you and you can understand it better. Have patience. Is that reliability and validity? Is the reliability and validity? Look at here. Look at here. My PPT is visible. Reliability, validity. Already I have shared this PPT to the organizer. You might have got this PPT. Look at here. What is written? The square root of AB is greater than interconstruct correlation. The diagonal values are square root of AB. The diagonal values are square root of AB, and off diagonal values are interconstruct correlations. Off diagonal values are interconstruct correlation. Now go to the Excel sheet. See the off diagonal values of this matrix. I am again highlighting. Off diagonal values of this matrix are interconstruct correlation, and diagonal values such as 0.754, 0.767, 0.762, 0.762, 0.785. These are all diagonal values. Again, I am repeating. The diagonal values are 0.754, 0.767, 0.762, 0.762, and 0.785. These are all diagonal values. These are all called as square root of AB. These are all called as square root of AB. And the square root of AB must be more than the interconstruct correlationship, or you can say the interconstruct correlationship are less than the square root of AB. Look at here. Look at here. Look at the square root of AB for comprehension. Square root of AB for comprehension. Look at what is the value? 0.754. Look at the respective off diagonal value. What are the respective off diagonal value? Look at, I have highlighted these 4 are the these 4, only these, please listen carefully. These 4 are the off diagonal values for comprehension. For comprehension, that means 0.524, 0.558, 0.528, 0.538. These 4 values must be less than the square root of AB. The square root of AB for comprehension is 0.754, and the off diagonal values which are interconstruct correlation 0.524, 0.558, 0.528, and 0.538. These are all lesser than 0.754. I hope all of you are clear. Had anything be not less than the square root of AB, then exactly that value will be seen as red highlighted area. Such beautiful Gaskin has made this Excel sheet. If any value will not less than the square root of AB, that particular value will be red highlighted automatically. If you practice, you will know. If in your research any particular value will not be less than the square root of AB, that particular value will be automatically red highlighted. Do not worry. So in my case, all the values are sufficiently less than the square root of AB. Now coming to the square root of AB for credibility. Look at my screen. Look at my screen. Square root of AB for credibility. It is 0.767. Its respective off diagonal values are what? Look at here. Its respective off diagonal value is, one value is 0.524. Another three values are this: 0.467, 0.486, 0.531. These three values plus this value, that is 0.524. These four values must be less than 0.767, which is justified here. Now look at the square root of AB for convenience. Square root of AB for convenience, that is 0.762. Now look at the respective off diagonal values. The respective off diagonal values are these two. First, one is 0.558, 0.5467, and these two, 0.558, 0.535, sorry, 435. So these two and these two, these four values must be less than 0.762 in order to prove that the off diagonal values are less than the diagonal value, which is square root of AB. Off diagonal values are in interconstruct correlationship. Interconstruct correlationship means what? Look at here. Suppose it is 558. It is the relationship between comprehension to convenience. Suppose it is 0.467. It is the relationship or correlationship between credibility and convenience. Suppose it is, look at here. Look at the box. Suppose it is 0.558. It is the interconstruct correlationship between convenience and compatibility. So interconstruct correlationship must be lesser than the square root of AB. Proven. Likewise for this, look at here, the square root of AB for compatibility. Look at my screen. Square root of AB for compatibility is 0.762. What are its respective off diagonal value? One of the off diagonal value is this, 0.539. Other three off diagonal values are this. Other three off diagonal values are this: 0.528, 0.486, 0.558. These three value and this value are lesser than 0.762. Likewise, come to the square root of carrying, CRI. Square root of carrying is 0.785. What are its off diagonal values? These are its off diagonal values. These four are its off diagonal values: 0.538, 0.531, 0.435, 0.539. So these four values must be less than this 0.785, much less. So the entire thing is second criteria of proving discriminant validity. What is that criteria? The off diagonal values must be less than diagonal values. What does it mean? Interconstruct correlationship must be less than square root of AB. So this criteria is proven. What was the first criteria? First criteria was both the MSB and ASB must be less than AB. Both the MSB and ASB must be less than AB. So both of the criteria of justifying the discriminant validity are proven in my research. All the criteria now I explained for the validity has been initially proposed by two famous authors. One is Fronell, second one is Lacker. I am showing this article. Already I have given this article to the organizer. You can cite that article. Look at here. This article. Let me click here. This article. Look at here. Fronell and Lacker. So you have to cite this article in order to give this criteria of proving the validity. Any thesis or article you are writing, this article might have been cited more than 1 lakh times. From that you can imagine how much of important this article is. This Fronell and Lacker. So directly you can say, according to Fronell and Lacker, the validity can be tested. Fronell and Lacker bracket में 1981. Fronell and Lacker bracket में 1981. The validity can be explained by convergent validity and discriminant validity. For the convergent validity, the AVE, average variance extracted must be, I think anybody is creating disturbance. The organizer, please mute them. The organizer, please mute them. So what the Fronell and Lacker are saying, the convergent validity can be proven if AVE, average variance extracted, will be more than 0.5. Later on, some other authors, not Fronell and Lacker, some other authors said if the composite reliability will be more than 0.7, then it is an additional criteria to say the convergent validity is proven. Again, coming to the Fronell and Lacker said if the average shared variance and maximum shared variance, ASB and MSB, will be lesser than AVE, then one criteria of discriminant validity is proven. Another criteria of discriminant validity is the square root of AVE must be higher than interconstruct correlationship, or you can say reverse, the interconstruct correlationship must be lesser than the average variance extracted. What is that called as square root of AVE? Square root of AVE must be more than interconstruct relationship, or you can say interconstruct correlationship values must be less than square root of AVE. Any one you can say. This is second criteria of discriminant validity according to Fronell and Lacker. This particular article I have already given. This is freely available. Do not worry. This article is freely available. Still, I have already shared to the organizer. They might have been sent you. So you have to cite this article. And you write, as I am saying, in your thesis or in your article, according to Fronell and Lacker, 1981, the AVE values are more than 0.5. So convergent validity is proven. According to Fronell and Lacker, bracket में 1981, all the diagonal values are more than off diagonal values. So one of the criteria of discriminant validity is proven. Again, according to Fronell and Lacker, the MSB and ASB are lesser than AVE. So it is well justified that according to standard of Fronell and Lacker, the discriminant validity and convergent validity are proven. So there is no concern of validity. Now, till now, if anybody is having any doubt, they can ask. Quick. Till now, if anybody is having any doubt, they can ask. Quick. So these are all about validity. Now coming to the reliability. What is that reliability? Already one criteria of reliability I have proven. The CR, composite reliability. CR is very important because it is proving the convergent validity. It is also proving the reliability. Again, the same standard. If the composite reliability will be more than 0.7, reliability is also proven. Now, what is the second criteria? As usual, the Cronbach alpha. What you will do, you will take all the values. You go to the SPSS file. I hope the SPSS file is open for me also. Go to the SPSS file, and you can directly take. Go to the SPSS file. Where is my SPSS file? I think I have not opened. Let me open that my SPSS file. If you go to the SPSS file, you can take those variables which are under a single constructs only. Those variables which are under a single constructs only, and see whether the Cronbach alpha is more than 0.7 or not. So likewise, you need to take separately the underlying indicators of every constructs and test the Cronbach alpha. It is taking some time. Let me show you one so that you can carry out accordingly. By the time, if anybody is having any doubt, they can ask. By the time, if anybody is having any doubt, you can ask. Bapan sir, you can ask. Bapan sir, you can ask now.
Sir, I could not make this in this your macro Excel, but I did it in the plugin.
Okay, then it is okay, no problem. Anyhow, these values.
Means, sir,
This.
Yeah, means. Yes, sir. In the means there is a runtime error. I think some technical problem is there. I need to verify, and I need to troubleshoot it.
Anyhow,
Yes, sir.
see.
Okay, sir.
Got your point. I got your
Yes,
point.
sir.
Listen now. I got your point. Listen now. If anyhow you are getting these values, now apply the standard. Nothing wrong.
Yes, sir.
Apply the
Yes,
standard.
sir.
Like one of the standard is ABE must be more than 0.5. Ho gaya. Done. Are you getting my point?
Yes, sir.
Anyhow,
Yes, sir.
see, even if you can calculate manually, no problem. Calculate manually by this formula. Look at here, the formula.
Yes,
I have already
yes.
shown you. Calculate manually
Yes,
by this formula.
As we did yesterday.
The formula of AB is summation of lambda square divided by n. Very simple. Formula of CR is summation of lambda square divided by summation of lambda square plus error, summation of error. Lambda means simply regression weights. Simply that standardized regression weight, nothing else. Under one construct, whatever standardized regression weights are there, like under one construct of my research, it was 5 construct. So the standardized regression of weight of those 5 construct you need to take. You need to square it first, then you need to add it, then you need to divide it by 5. Ho gaya. This is AV. This is AV. So again CR. First sum the lambda square, then square it. Sum the lambda square. Sum the lambda, then square it. So sum the lambda, then square it. That value put in the numerator. The same value put in the denominator plus error. What is error? 1 minus lambda. 1 minus lambda is the error. Respective from every respective. Look at the table, simple table in my PPT is visible. The error means 1 minus lambda. That means a respective indicators regression weight you need to deduct from 1. That is error. Likewise, from every respective indicators regression weight, 1 from that you need to deduct and you need to add sum. Ho gaya. So you need to sum the lambda, then square. That value put in the numerator, the same value put in the denominator, plus in the denominator you put the values of sum of error. Now you will get the CR. If anybody is facing problem, simply they can calculate manually in the calculator, pen and paper. Do not worry. Simply do not worry. You can calculate pen and paper and prepare a table. Ho gaya. Are you getting my point, Bapan sir? Getting my point?
Yes, sir.
Yes, sir. So you can calculate according to the formula in pen and paper, and you can create a table in your Word file. Nothing, no problem at all. Anyhow, you need to prove that AB values are more than 0.5. MSB and AB values, ASB values are less than AB. diagonal values are more than off diagonal values, anyhow you need to prove. Then validity is proven. I hope all of you got. What is happening to my SPSS file? I am not getting at all. What is that SPSS file? What is happening? Till now my SPSS file has not been opened. Once it will be opened, do not worry, I will show you the simple process as you are doing in your MBA or MPhil. The simple process, you need to open the SPSS and you need to do the Cronbach alpha calculation. Whenever it will be open, I will show you, do not worry. Now these are all validity and reliability. Till now in validity and reliability, if anybody is having any problem, you can ask. Then some of the recent researchers, please look at here, some of the recent researchers are not satisfied with this criteria of MSB and ASB, because MSB and ASB can randomly vary based upon the specification of your model. Suppose I have specified 5 indicator, you will specify 6 indicator, somebody will specify 3 indicator. So according to that, it may vary. Some of the recent researchers, so anybody is asking anything? Okay, some of the recent researchers do not agree on that. So that is the reason 2 famous authors, look at here those authors, I'm showing you how to control. Look at these 2 authors, Hancock and Muller. Look at these 2 authors, Hancock and Muller. They said obviously the MSB and ASB, these are not the accurate judgment of discriminant validity. These are not accurate judgment of discriminant validity. In some cases, not accurate judgment of convergent validity also. So they proposed one of the very decent criteria, that is maximal reliability. Maximal reliability denoted as MAX R, then in bracket H. So this is shown in the recent Excel sheet. This is shown in the recent Excel sheet. This Excel sheet you can download directly from the start week. Can anybody answer whether my recent Excel sheet is visible to all? Visible to all?
Yes, sir.
Yes, sir.
So now see, that particular maximal reliability will be visible in the recent Excel sheet. I am doing the same procedure. Look at here. I am going to the output of AMOS file. I am going to the output of AMOS file. Then copy the correlation table. Going to the recent Excel sheet of the reliability validity master, and then paste it. Then paste it. Then go to the again AMOS output file. Then go to the regression weight. Then copy it. Then go to the AMOS validity master. Then paste it here. Paste it in the F1. Paste it in the F1. Then simply go to the click me and click. Now see the magic. Now see the magic. Instead of ASB, there is a value appearing max RH. All of you have seen? All of you have seen the max RH? All of you could see the max RH?
Yes, sir.
Anybody
Yes,
can answer?
Yes, sir.
So this is in total called as maximal reliability. Maximal reliability, max RH. So these 2 famous authors has proposed that initially, that Hancock and Muller. You need to cite this article. Actually, this is an article of a book, but this article has taken more than 35,000 citation till now. That means more than 35,000 in the yes, 35,500 something. That means 35,000 article has cited this particular article. Rethinking construct reliability within latent variable system. That means for our CFA or ACM. So Hancock and Muller, you need to cite this article. All these articles are freely available. Do not worry. Still, I have shared with the organizer, and they will share it. See, Hancock and Muller. What is the year? 2001. Hancock and Muller 2001. You can cite, and you can say according to Hancock and Muller. According to Hancock and Muller, the maximal reliability denoted as max RH should be more than 0.7. Nowadays, some of the authors are saying it should be more than 0.8. However, in my research, both of the cases are proven. The max RH values are more than 0.7, also more than 0.8. More than 0.7, you can accept it, do not worry. So all the values of maximal reliability for all the constructs like comprehension, credibility, convenience, compatibility and caring, all the values of maximal reliability are more than 0.7. Hence, the discriminant validity is proven. The discriminant validity is proven. That means there is a very less scope. Please have the concentration. That means once you say maximal reliability is 0.841, how much is left? How much is left? It is 0.159. 159 is the
Yes.
see
Yes.
only
0.1.
only 0.159 scope is there, that any other indicator may describe this construct, which is very minimal. That means both the convergent validity, especially the discriminant validity is proven, especially the discriminant validity. Why? Very less scope is there. Any other indicator can explain this particular construct or latent variable or factor, whatever we say, construct or latent variable or factor. Very less scope is there. What does it mean? The cross loading is very minimum, negligible. So the convergent validity and discriminant validity is very strong and perfectly proven. So all other criteria remain same. What is that criteria? AB should be more than 0.5, MSB should be less than AB, composite reliability should be more than 0.7. And for another criteria of discriminant validity is the diagonal values must be more than off diagonal values, or you can say off diagonal values must be less than diagonal values, which is called as the square root of AB must be higher than interconstruct correlationship, or you can say interconstruct correlationship must be less than square root of AB. This is second criteria of discriminant validity. All other things remain same. In the recent Excel sheet, which you can directly download from the start week, this is available. Already I have 6-7 years back that old file, so I have shown you. Otherwise, this file is available in the start week. So now the most important thing the article reviewer or thesis examiner are looking for is reliability and validity. I have covered. Anybody want to ask any question till now, you can ask. And I have taken 1 hour already of the previous day class, so I should not take more time. I should directly go to the today's class. If anybody is having any problem, they can ask. Now over to you, audience. Over to you, participant. Anybody is having any problem? Anybody is having any problem? Are all of you are understanding or not? All of you are listening, or some of you are simply the passive listener? I am very much confused. What is happening to you? What is happening to you? Are listening?
Yes, sir.
There is somebody's name, Saroj call.
Yes, I'm listening. I'm carefully listening. I'm carefully going over your word by word.
Okay. Very good. Somebody is Bandhan. Are you listening? Bandhan,
Yes,
are you
sir.
listening?
Yes, sir. Yes, sir.
Okay. Anybody else? Bapan, clear or not? Bapan?
Yes, sir. Clear.
No, still, if any doubt is there, you can ask, because this is very important for the thesis examiner and article reviewer. Any problem in your reliability validity, they will directly reject your article. And that is a great question mark in your thesis if there is a problem in reliability and validity. So I hope most of you are only logging in and not listening at all.
Sir, can you please explain? Means you said only 1 point something. Something has means I was not totally aware of that thing, sir.
Bapan sir, you are not listening. Bapan sir, you are not listening carefully. Not 1 point, point 1. Point 1 I said, not 1 point.
So point
Please.
1, sir, how can we know?
Listen, sir, listen. Look at here. The maximal reliability for the comprehension is 0.841. Could you see my screen?
Yes,
you
sir.
Screen my screen? Sir, say yes or no. You are asking a question and remaining silent. 0.841.
No, sir. I am saying yes, sir.
1 minus 0.841. How much? How much? It is
okay.
0.159.
Yes.
Yes, sir.
This much scope is there that other indicators can explain the construct comprehension. look at the AMOS file. Look at the AMOS file. Look at the comprehension. Look at the comprehension. BSI 19, BSI 20, BSI 21, BSI 22. Apart from the 4 indicator, if any other indicator you say, they have only 0.1% probability that they will explain the comprehension, which is very negligible.
Okay.
Which is otherwise called as cross loading. Suppose BSI 18 will be loaded on comprehension. That means the validity and reliability is not proven. Cross loading should be negligible or zero. Zero to kabhi nahi hoga. Cross loading must be negligible, so that your the model specification on model identification is very much high. Got my point, Bapan sir?
Yes, sir.
Likewise, the max RH value for the credibility is 0.879. 1 minus 0.879 is how much? That much value or that much probability is there, or that much regression weight is there remaining for rest of the indicator to explain the credibility construct, which is very negligible. In my case, it is 0.8 above. Even if it is above 0.7, also you can say less than 30% probability is there. Other indicator can explain the concerned construct, underlying construct. That means that is not significant. That is negligible. Now clear? Bapan sir, clear?
Clear, sir. Clear, sir.
So anybody else? I think somebody is Monisha Khanna. Are you listening, madam? Somebody is Monisha Khanna. Are you listening? Somebody is Paramjit Kaur.
Yes, sir, I'm here.
Understood every point of reliability and validity?
Yes, sir, I did. But actually, practically, I cannot be able to do. There is runtime error while doing. But definitely, what the way you explained, we can definitely refer once we get over it.
But procedure you understood?
Yes, sir.
And the standard of proving the reliability validity you understood?
Yes, sir. That's what I was listening.
Then everything is clear. Do not worry. If procedure you understood and standard to prove the reliability validity you understood, then everything is okay.
Yeah,
No problem.
yes, sir. Maybe
No problem.
as you said, if something technically there is an error, we can do it manually and work it out on that.
Do not do.
Yeah.
See,
Thank you.
simply the files I have sent you, you can enable the macro property by going to any technician of your lab. Nothing wrong with it. Huh? Okay. So
I
all of
enable
you
the
are,
macro, sir. I enable the macro, but when we do it, when we click on the calculation part, then there is runtime error. I think that is a programming error, something. So we'll definitely get it done by some technical person only.
I think if you have any original antivirus software, they are breaking the path. So you can you can go to the your antivirus software. You can allow.
Okay, sir. I'll do
Some cases, in some cases, not in all cases. In some cases, the original antivirus will break the path. So you can go to the antivirus setting and allow the macro. Clear?
Okay, sir. Fine. I got it.
Then somebody is Prerna Singh. Are you getting? I hope people are logging in and they are leaving. So nothing to do with, at least those who are listening, they should understand. Sarika Sahu, are you listening? Are you listening?
Yes,
And understood everything?
sir, I am listening.
Understood
Yes,
everything?
sir. But sir, I am unable to access the Excel, sir. But I am listening, sir.
But procedure you followed?
Yes, sir.
Procedure you followed?
Yes, sir.
अरे तुरंत yes sir बोलो. Okay.
Yes, sir.
Okay. See, now we will go today's topic without getting late. Today's topic is this. Look at here. Today's topic is this. That is reflective versus formative measures. And another judgment of the SCM and CFA, that is common method biasness, CMB. I will go to the CMB later on. Now I will ask and I will explain the reflective versus formative measures. What is this? Till now, whatever explanation we have made in the AMOS, these are all the reflective measures. These are all the reflective measures. Let me explain. Let me. These are all the reflective measures. Why reflective measures? You are measuring. Okay, let me go to there. You are measuring the construct. You are measuring a construct by various attributes. Hence, you are saying that construct is reflected through. Please look at here. The arrow mark is going towards the indicator from the construct. The arrow marks are going towards the indicator. Indicators are squares or rectangles, and the construct are oval sides. So this is what the reflective in nature. What is that? Reflective in nature is saying that the construct is measured by the indicators. That means the construct is reflected through the indicators. That means the factors are indicated through the your independent variables or exogenous variables. The construct or latent variable or the factors are reflected through the independent variables or exogenous variables or indicators. Do not worry, all these things will be explained, and this is the way it is reflected. That means the arrow mark will go from the construct or latent variable towards the indicators, towards the square or the rectangles. Now look at here, what is reflective measurement? A reflective measurement do model the theory based upon the idea of latent variable or latent construct, which is caused by that latent variable. That means the latent variable is reflected through by some measurement score plus error. Try to understand. So that is the reason the covariance based structural equation modeling is very important, because it is counting or it is considering the error very strictly. What is written? Please have a look. A reflective measurement is modeling the theory based upon the idea that latent variable caused the measurement variable. That is the reason the arrow mark is going from the latent variable towards the indicators. The arrow mark is going from the latent variable towards the indicator, causing the indicator or exogenous variables or independent variables. As because it is causing the independent variable, it cannot cause the independent variable fully, so some errors are there. So how the errors are indicated in SPSS? By this way. Look at here to my screen, by this way. Likewise, the latent variable is causing another indicator, that is again this. Again the same logic, it is cannot cause the indicator fully, so hence again there will be a error term added here. Likewise, the number of indicator you have identified through literature review, you can go on putting, you can identify first, then you can assign that particular construct. Likewise for other construct, this is for one construct. Likewise for other constructs, you can show it. So I have shown you the 5 constructs CFA. So what the reflective measurement says? Reflective measurement says, as much as time you ask the question, what is the indicators? Indicators are nothing but the items of your questionnaire. As much as time you ask this item of the questionnaire to the respondent, nearly the same or exactly same answer you will get. This is what the most important property of reflective measurement. If not, the research design of your research is wrong. You should not go by reflective measurement. So that is the reason, as because the number of time you will ask those set of variables. Suppose under F1, 5 indicators are there. I am asking now, I am asking tomorrow, I am asking 1 month after, near about the same result I will get. That is the reason all the 5 indicators are expected to be highly correlated. Try to understand. That is the reason all the 5 indicators of my example F1, that is comprehension, are expected to be highly correlated. But this expectation you cannot make in case of formative measurement, that I will explain after this. Do not worry. All the 5 indicators are expected to be highly correlated in my example of F1. Because it is said that it is found out that all the 5 items of your questionnaire are producing the same or nearly the same result over the time period if you ask the same respondents. So what I am operating now, that I have already written. Look at here, AMOS software measures only the reflective model. So most of the time what the student do, what the scholars do the mistake, they are saying ki attitude is causing the satisfaction. They are showing the model like this. And they are adopting the AMOS, which is wrong most of the time. If your measurement is reflective in nature, then only, not formative in nature, then only you should adopt the AMOS. But most of the time, the scholars or students do not understand. They write everything in the thesis in a causative manner, but adopt the AMOS. As because they are thinking AMOS is very great thing, I will put it, I will take the WAWA and they are putting it. Suppose attitude towards classroom, attitude towards the virtual class, attitude towards the teacher, attitude towards the university are causing the student satisfaction, That means it is formative in nature. If you are judging this and doing everything in the AMOS, then two things are contradictory to each other. If you say, if your literature say that reverse, kaise? If your literature say that the student satisfaction is reflected by attitude of students towards classroom, attitude of students towards virtual class, attitude of students towards the teacher, attitude of students towards the environment of campus, university campus. If you say like this and adopting AMOS, then it is okay. But if you are saying causing, try to understand. Attitude towards class is causing the satisfaction. Attitude towards the teacher is causing the satisfaction. Attitude towards the virtual class is causing the satisfaction. And you are writing the thesis or article in this manner and adopting the AMOS, then it is contradictory to each other, it is wrong. Very funny thing is, in some cases, in the initial part of one of my scholar asked me, sir, the arrow mark should be towards the construct, and you have the AMOS is wrong. Hey, how come the AMOS is wrong? Then entire world who have prepared the IBM, they are mad. He is asked, sir, this should be the arrow mark should come towards the construct, but you are making reverse. Ulta bol diya aapne. The arrow mark is going towards the indicator from the construct. But by that time, I have not explained and they have not understood that there are two measurements in CFA and SPSS mostly. One is reflective, one is formative. We are doing the research in a reflective measurement. So most of the time students confuse it. Do not confuse it at all. That is the reason by saying to the organizer, I have put this particular topic in one of the session. Now coming to the formative. Look at here, formative. So formative measurement cannot be done in AMOS. Repeatedly I am saying. Formative measurement cannot be done in AMOS. Formative measurement do in a particular software very much called as Smart PLS. So many other software there, but this is very popularly used by various researchers nowadays. What is happening in the formative measurement? As I said now, these four attitude is causing. See, look at here. Let me do the make the attitude in square or rectangle so that the understanding error will not happen. So suppose these four attitude I said right now. These four attitude I said right now is causing the satisfaction of student. Attitude towards classroom is causing the satisfaction. All of you please look at my screen. I am preparing a graph. I am preparing a model. Attitude towards the classroom is causing the satisfaction. Attitude towards the teacher is causing the satisfaction. Attitude towards the campus environment is causing the satisfaction. Attitude towards the virtual class is causing the satisfaction. If your research is going by this direction, yani ki your objective has written in this regard, then you can adopt the formative measurement, which can be done by Smart PLS, not by the AMOS, not by the AMOS. So that is the reason exactly that I have done here. I have written, look at here. Every independent variable is connected to the factor which is oval size by default. That means the way we are doing in the AMOS one by one, it will be taken directly. That tree will be taken directly. And arrow mark will be directed from the indicator to the latent variable. But in the AMOS, what is happening? Arrow mark is drawn from the latent variable to the indicator. In the AMOS, arrow marks are drawn from the latent variable to the indicator. But in the formative measurement, arrow mark will be drawn from the indicator to the latent variable. Very simple. And underlying assumption, underlying theory I have already said. Do not worry. If your literature substantiate that attitude is causing satisfaction, then you have to adopt formative. If you do not find out such thing, then you should not go for formative. But most of the time, the MPhil PhD students, they do this. They are writing the thesis in a formative language, but they are adopting AMOS, which is contradictory. So the summary and conclusion is what your literature is substantiating. You go by that way. So sufficient literature you do. Most of the literature, if they are saying formative, then go by formative. Most of the literature on your topic, if they go by reflective, then go by reflective. Nothing wrong. Now look at the difference. Now look at the difference. What is that? Causal priority. I have already said. Indicator are realized from the construct. Realized from the construct. From. But here in the formative, indicators are explanatory. And from the indicator to the construct, that I have said just now. Now look at here, measurement error. In the reflective, establish the practice of important at an item level. Please try to see this. Every item has attached with a error term. Every item is attached with a error term. But here, that is not the case at all. In the smart PLS, you cannot see that is the case at all. Let me see this. Okay, look at here. Look at this diagram. Look at the diagram. This is the formative. This is the formative diagram. There are arrow marks from the indicator to the construct. I have directly taken a beautiful diagram from a famous article just to show you, nothing else. This is formative. This is formative. So the arrow marks are going from the indicator to the construct. But in case of reflective, what was happening in our case? Look at here. Look at here. Here it is reflective. Here it is reflective. Look at my screen. Reflective. The arrow mark is going from the reflection, from the construct to the indicator. To the indicator. So the same thing, that case study I have said you, in one of my research, one of my scholars, this has happened. The attitude is causing the attitude is reflected to, sorry, satisfaction is reflected through the attitude. And others has not done, not realized that. They asked the scholar, how come you are doing a mistake? The arrow mark should flow towards the satisfaction. Arrow mark should flow towards the satisfaction. Then that scholar asked me, sir, what is happening this? Then I said, what your literature says, please read. His literature said satisfaction is reflected by, in most of the cases, by attitude. Then what the arrow mark should be? The arrow mark should be from the satisfaction towards the attitude. That means it is reflective, not conformative. If your literature is substantiating that attitude is causing the satisfaction, then you do accordingly. See, likewise, this is a beautiful example what I have taken, why I have taken. Look at here. One of the construct that particular researcher has taken as formative. Another construct, the same research, same article has taken as reflective, same article. This is a real article of a journal I have taken. Look at this. You can see this. It is freely available. In the source I have put it. In the source I have put it. You can download it. These two authors, Fries and Raske, see, they have measured one construct. They have measured one construct by formative way, another construct by reflective way. Another construct by reflective way. But however, the recent researchers are not obeying this rule. They are saying your research is either formative or reflective. Both the things cannot be conducted in a single research, which is contradictory to each other because of the error term. Because of the error term, they are contradictory to each other. The recent researchers are saying you should not adopt in a single research both the formative and reflective. You should not adopt because of the error term. Because there is no scope of error in case of formative, and the error terms are rigidly taken in the reflective. Rigidly taken in the reflective. So how will you justify to the construct which is formative? How you will justify the error to the construct which is formative? The construct which is formative in nature, how you will justify the assumption of error for that construct? There is no scope. So you should not do a research where both the reflective and formative are adapted. However, some article you can see Some article you can see both the reflective and formative has been adopted, but the recent researchers are not obeying this. They are saying no, it should not be. Okay, let us go backward. Then what has happened? Indicator should process internal consistency in case of reflective, but such internal consistency is not implied here. It's not expected here because x1, x2, x3, x4 are causing something. There is no meaning of internal consistency. If you say F1 is reflected by x1, x2, x3, x4, then there is a requirement of consistency. Try to understand. F1 is reflected through, try to understand, F1 is reflected through x1, x2, x3, x4, then there is an expectation that there is a high correlation or covariance among x1, x2, x3 and x4. If you say x1, x2, x3 and x4 are causing F1, then there is not necessary, no necessity at all to say there is a correlation, because they are causing as a whole. They are causing as a whole. So there is no necessity of saying there is an internal consistency. So the meaning of internal consistency is not required in case of formative. Another reason why some article reviewer or thesis examiner are not agreed upon the smart PLS, because of this. If you are unable to say there is an internal consistency, then probably the projection of sample result to the greater population is not valid. You cannot say that your sample result can be projected towards a greater mass. That means the generalizability criteria that you understand from the very MBA or BCom career, the generalizability criteria of research has not been proven. So likewise, some other rules are there. Rule of 3, 2 eminent path plus formative. So these are all the things here. Some other differences are there. So you can understand that under every difference I have mentioned the source. These are all freely available. You can also read that particular article. No need to worry. Now this is what the scene I have shown. Now look at here. Look at here. The most important question is, in case of formative, how the items of the questionnaire should be written. See, that is the most important question. That is the most important question one scholar should ask. What should be the language of questions in the questionnaire in case of formative? What should be the language of questions or items in the questionnaire in case of reflective? Because these are greatly differ from each other. Look at the reflective statement. I eat healthy food. Look at the formative. I have a balanced diet. That means it is causing. I eat healthy food. I do not eat. Sorry, I think it is each. I do not take. I think somehow it has been written wrongly. I do not take much junk food. I have a balanced diet. Although here it is written I have a balanced diet, this is reflected. But please listen, please read the formative statements. I have a balanced diet. I exercise regularly, cause. Exercise regularly, it is causing. I get sufficient sleep each night. It has causing. Again, I am coming to the attitude, suppose. The same example I was saying. Attitude of students towards the virtual classroom. How you will ask? I enjoy the virtual classroom. I enjoy the virtual class. It is reflective. The same question, how you will ask if it is formative? Virtual class make me satisfied. Virtual class make me satisfied. I enjoy the virtual class. It is reflective. Virtual class make me satisfied. It is formative. I repeat. I enjoy virtual class. It is reflective. Virtual class is satisfying me more than the offline class. It is formative because it is causing. I enjoy the campus environment. It is reflective. Going to the campus environment, if I go to the campus environment, then my satisfaction increase. It is formative. If I go to the campus environment, my satisfaction increase. It is formative. I enjoy the environment of my university. It is reflective. Go to the another statement. Attitude of student towards the teacher. I enjoy the teacher's wordings. The teacher's wordings and way of explanation make me satisfied. The teacher's wordings and explanation make me satisfied. It is formative. I enjoy the teacher's wordings and explanation. It is reflective. It is reflective. I enjoy the teacher's wordings and explanation. It is reflective. Teacher's wordings and explanation make me satisfied or enhance my enjoyment in the classroom. It is formative. I hope you are clear now, till now. I hope you are clear till now. I hope you are clear till now regarding formative and
Yes,
method
sir.
and reflective.
Yes, sir.
Yes,
Thank you.
yes, sir. Yes, sir.
So half of the today's session is over, and next half is very important. Next half is very important. What has happened today? Okay. Now that see, I was saying you earlier how to test the reliability of every construct. Look at here. All of you could see my SPSS sheet. Anybody can answer yes or no?
Yes, sir. Yes, sir.
Okay. I was saying how to measure the reliability of every construct through Cronbach alpha. This is one way of judging the reliability of construct. Already I have said another criteria, that is composite reliability, CR. That part is over. Now I was unable to open the SPSS sheet, so I could not say you. Now it has been opened. Now I will show you how to test the reliability of every construct by another criteria, that is Cronbach alpha. Simple, very simple step that you are doing in your SPSS, in your MBA or MPhil career. That is, whatever indicators are there under a particular construct, only those indicators you take to the analysis. See, BSI 1, BSI 2, BSI 3, BSI 4, BSI 5. Only these 5 indicators are coming under F1. So what I will do, go to the analyze, go to the scale. Look at here, go to the scale. Then go to the reliability analysis. That usually you do. Go to analyze, go to scale, go to reliability test, reliability analysis. Click there. Click there. Only you take BSI 1 to BSI 5 for F1. For F1. Only you take BSI 1 to BSI 5 for F1. And run BSI 1 to BSI 5 for F1. And already chosen the alpha, Cronbach alpha C. If any other statistics you require, you can select here. You can select here. Just to show, nothing else. Just to show, nothing else. Otherwise, alpha is checked, alpha is ticked. So no need to worry for that. Just just to show here. Continue. Then okay. Then okay. Look at here. Look at here. See, the reliability for F1 construct is near about 88%. 0.877 means you can say near about 88%. That means satisfactorily above 0.7. Likewise, you need to take BSI 6 to BSI 10 for F2 separately. Likewise, you need to take BSI 11 to BSI 14, 4 variables separately for F3. Likewise, from BSI 15 to BSI 18, you need to take separately for F4. So separately you take and take this value only to your table. Take this particular value only to your table. What you generally do, whatever table has been produced, what generally article writer are doing, whatever table has already been created, look at here. Look at here. This table directly you take to the Word file and insert another column here along the CR and put the value of Cronbach alpha. हो गया. You directly take this particular table to your thesis word file and insert another column nearby to the CR and write the heading as Cronbach alpha and put all the separate value that you have obtained separately. Write that. Done. In a single table, done. Both the reliability and validity done, both single table. I hope all of you understood. I hope all of you understood up to this.
Yes,
Understood,
sir.
all of you?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay. So, okay. The next part of today's session is, I hope time is there today. So the next part of today's session is another important assumption or another important testing, that is common method biasness. Try to understand. It is very important in the modern research. Common method biasness, it is very important in the modern research. Are you all listening? If any doubt till now, you can ask. Are you all listening? If any doubt, you can ask till now. Bapan sir?
No, sir. Thank you.
Yes, sir. Yes, sir. We are with you, sir.
Okay, very good. Thank you. So another important assumption, not exactly assumption, it is testing. Please recall my first session. What I was saying, item response theory, and there is a theory called as the traditional theory by which error is calculated.
Classical
Yeah, very good. Classical
test theory.
Yes, classical theory. Classical theory and item response theory. Both of the theory, what they say, what is the common in both of the theory? The common thing is both of the theory is, in case of classical theory, the entire value is just at a whole. The entire values are just, anybody is asking? Okay. Please mute yourself. Okay. Okay. So in case of classical theory, please mute yourself. The entire value in case of classical theory is just at a whole, but in case of item response theory, every item do possess a particular error, whatever it may be, but the common thing is error. In the classical theory, what was happening? The observed value is equal to the observed score. The observed score is equal to true score. True score plus error. The observed score is equal to true score plus error. This is as a whole. In case of item response theory, for every items you are calculating, the observed score is equal to the variance that is explained by that, indicator, that is true score, plus error. That means you are assuming that whatever test method you adopt, this will happen. But over the time period, the moment test method has been changed, just like I said, formative, reflective, there are two test methods. Just like I said, formative, reflective, there are two test methods. Just like before that, I was explaining for the your discriminant validity and reliability, there are two to three methods. So many other methods are there. I explained you 2-3 important methods. So if method changes, there is an expectation of error also. This is what some of the researchers are arguing. The method do inherit some error. All the method, like starting from the method of collecting the data also. I am collecting the data by questionnaire. The same thing you are doing by a interview schedule. Try to understand. Please listen very carefully. I am collecting by questionnaire. Two important instruments that our management researchers use. One is interview schedule. Another one is questionnaire. I am adopting the questionnaire. You have taken the same items and you have taken the data through interview schedule. That means you asked directly one by one. In interview schedule, what is happening? The researcher is asking directly one by one to the respondents and recording. Who is recording? Researcher is recording. In case of questionnaire, who is recording? The respondent is recording. Respondent is answering. That means method has changed in the data collection. So some of the researchers nowadays, most of the researchers, not some, most of the researchers are arguing that when method changes, every method do inherit some of the error, do inherit some of the error. So where is that error? Where is that error? That means some error is because of measurement, some error is because of item, some error is because of sample, but some error is because of method you are adopting. Method you are adopting in the data collection, method you are measuring, method by which you are calculating, some error. So now we can say plus the error due to the method. So that the researcher is expected to control. Thereby it is expected, it is assumed that there is no common method biasness. There is no method biasness in your research. For this purpose, it is expected. Now we are saying assumed. It is expected. Now we are saying assumed that your method of adopting the questionnaire or method of data collection, method of data analysis, method of interview do not create that much of disturbance. I am assuming that. I mean, researcher is assuming that. Or error due to the method is negligible. Error due to the method is negligible. How to test that? One of the most important tests is common method biasness, CMB. I hope all of you are clear. I hope all of you are clear till now. The common method, the fundamental of common method biasness. That means what the CMB says. CMB says variations or disturbances are happening. The disturbances are happening by the method, not by the variance in predisposition of the respondents. Respondent का दिमाग में डिफरेंस नहीं है, डिफरेंस है मेथड में. The variations of data, the variations of data not in the respondent's predisposition, not in the respondent's mind, but in your method. That means there are some error disturbances in your method, but you are writing the result in your thesis that the respondents are different. There is a significant difference between male and female respondent you are writing. There is a significant difference between, suppose you are adopting ANOVA and you are writing difference. And you are writing, there is a significant difference between high income, low income. There is a significant difference between male and female respondent. But it has been seen that because of your method, some differences has been created. Actually, the difference was not there in the respondent's mind. So, not because of the respondent's psychology, but because of method, the difference created, which is error for us, which is assumed to be negligible. How to test that? How to test that? Herman, one of the expert or professor, proposed simply you take all the items to the explorative factor analysis. We are discussing now CFA, confirmatory. You are adopting the explorative factor analysis from your MBA career. What the general factor analysis students used to say, that is actually explorative factor analysis, EFA. I have already explained the difference between EFA and CFA, I think, in my second session. So that the general EFA you are adopting, factor analysis people are adopting, that is EFA. So it's the same way, the same factor analysis EFA you take, all the variables, in my case are 22 variables, all the variables you take to the EFA, and what you are doing, you are giving the freedom to the SPSS that the SPSS will correlate and will produce the construct or will produce the factor. But in case of Herman's one factor theory, Herman is saying there is an option in SPSS that you specify one factor will be produced. In my case, all the 22 variables I will take to the SPSS factor analysis. I will specify only one factor to be produced instead of giving freedom to the SPSS to produce as many as the SPSS wish by correlating. I will show you not. If by constraining by one factor, your cumulative variance will not be more than 50%, then there is no fear of common method biasness. If your cumulative variance is more than 50%, there is a threat of common method biasness. Now I will go to the SPSS. Instead of saying, I will directly go to the SPSS so that you can understand. This. Let me go to the SPSS. Where is that SPSS file? Where is the, okay. See, in general SPSS, what you used to do in the MBA or MPhil, you are going to the dimension reduction, going to the factor, click there. What you used to do, आप लोग क्या कर रहे हैं मैं पहले बता रहा हूं. Then I will go to the Herman's one factor theory. What you used to do, you are taking all the BSI 1 to BSI 22, which is buyer-seller interaction. See, so many other variables are there in my research, but I have taken only buyer-seller interaction. I am taking this. Then what I require, I will signify. I will check it. I will tick it. Then going to the extraction, I will check it. Then going to rotation. I am making Varimax rotation. Most of the researchers do, most of the students do Varimax rotation. Then go to the option. Then sort by size. If you can suppress, most of the time strict researchers suppress it more than less than 0.5. I also do that. You can make it more than 0.3. Continue. Then you click. The factor analysis is running. You can see factor analysis is running. Factor analysis is running now. Look at here. This is the factor analysis you do, which is popularly called as EFA, exploratory factor analysis. Look at here. I have taken, look at here. My screen is visible to all. Anybody can answer yes or no? My screen is visible?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now look at here. This is the factor analysis people generally do, students generally do in MBA and MPhil, which is popularly known as EFA, exploratory factor analysis. What has happened? 22 variables has been taken and 5 factors have been extracted. 5 factors has been extracted and cumulative variance is 68%, 68.503. Look at my cursor movement. Cumulative variance is 68.503. Done. But in case of instead of giving freedom to the SPSS, rather we can say freedom to the equation. What is that equation? Covariance or correlation equation. I will not give the freedom to the equation to produce the factor. I will specify I need one factor. How to do that? Let us see. This is the thing you are doing in your general factor analysis. But this is the thing we will not do for our common variance test, common method variance test. I will not do that. Just in order to make you difference, in order to show you difference, I am showing here, nothing else. So what I will do, the same process I will do, but see the difference. Go to the dimension reduction, go to the factor, click there. You have taken everything. What the Professor Herman proposed this, how to test the common method biasness. Do this, then do not do the rotation. On-rotate. That means by default it will be on-rotated none. You leave it there. Do not rotate it. First indication, first assumption or first testing point is do not rotate it. जबकि EFA में rotation जरूरी है. But in Herman test, do not rotate it. Leave it unrotated. This is the most important criteria of testing Herman's test. Do not rotate it. Leave it none.
So here we don't need to click on Varimax here.
No, none.
Okay.
No rotation at all. It is the proposal of Herman. Clear?
So, but in EFA we had clicked on Varimax, I think.
Yes.
Okay,
In the EFA you click on Varimax. Okay. Now, what is the second thing which is very most important according to Herman? Go to the option. Where is it? Let me extraction. Go to the extraction. Please look here. By default, it will be based upon eigenvalue. But in according to Herman, you need to fix one. I need only one factor. If I give the freedom to the SPSS, how much factor the SPSS has produced? 5 factor. Now you will see only one factor will be produced. I have specified I need one factor. According to Herman, you do this. I need only one factor. You fix one factor. Continue. Rest all the things are okay. Only these 2 things you need to do. You need to leave, not to rotate. You need to specify one factor. Do not give the freedom to the equation or to the software to produce as many the software want. Okay. Now click OK. What is happening? Let us see. What is happening? Let us see. The same table will be created. Look at here. The same table has been created. According to my choice, software has given me only one factor. Look at here. All of you able to see my screen? All of you able to see my screen?
Yes, sir. Yes.
Okay.
Yes, sir.
Okay. According to my choice, software has given me only one factor. How much cumulative variance it is giving me? Near about 38%. That means 37.883 means near about 38% cumulative variance the software is giving me, which is less than 50%. According to Herman's standard, after producing one, where is that? After producing only one factor, if your cumulative variance is less than 50%, then you are safe. That means no common method biasness. In my research, I am safe. There is no common method biasness. If your cumulative variance after producing one factor is more than 50%, then you are in danger. That is a common method biasness. That means the error is because of mostly by your method, not by real difference among the mind of the respondent. You want to judge the real difference in the mind of the respondent, but your method has created the disturbances. What is the logic behind it according to Herman? Herman is saying if one factor is explaining more than half of your entire variance is 100%. If only one factor is creating your entire variance, more than half of the entire variance, then there is a problem in method. Your method has exaggerated. Really there is no difference. Really it is not the reflection of respondent's attitude or mentality. Your method has created this. Your method has exaggerated this. If only one factor is explaining more than half of your entire variance, 22 variable I have taken, and only one factor is explaining more than 50%, more than half of the entire variance. How come it is possible? That means it is a problem lies with the method, according to Herman. Herman's single factor theory. Herman's single factor score. This is popularly called as Herman's single factor score. This test is popularly called as Herman's single factor score. Got it, all of you? Got it, all of you? Any problem till now? Any problem? No, any doubt?
No, sir.
I think somebody has unmuted, so that there is a horn sound. Please mute. The organizer, please mute it. Unnecessary disturbance is created. Somebody's vehicle sound is creating the disturbance. We are discussing the disturbance of method. Here it is the disturbance of the participants. Okay. So this is the common. So many other tests are there. I think time does not permit. Let me. All of you can sit for another 5 to 7 minutes, 10 minutes. If you say yes, then I will go for.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes.
Okay. Your voice is breaking, sir.
Okay, let me stop my photo or picture so that it may enhance, my voice may enhance. Let me stop my. Hello, now am I clear? My voice is clear?
Yes, sir.
Sir, I have a question. If it is above, above 50 or slightly above 50%, then what would be the interpretation? Like,
Madam, initially your sound was very clear, but later on it has been diminished. Ask me again.
Sir, if I'm saying, as you said, if it is less than 50%, then there is no issue with CMB. I mean, we need not to. But if it is above that, say, for example, 60 to 70%, then what should we, how we can go ahead with one factor? I
got your question. There are so many ways. First, what you need to do, you have already collected the data while you are analyzing. Now you cannot do anything else to data. The first thing, the first solution to most of the statistics problem is enhance or increase the sample size. Enhance or increase the sample size by 10 or 15 or 20. Number one. But most of the scholars said, sir, I have already collected the data. Now in the final stage of my thesis, it is not possible. Okay, leave it. If you have sufficient data, suppose you have decided your sample size is to be 300 and you have 350 data. Suppose you have sufficient data. That means sufficiently more than the sample size. What you will do, you need to identify some outliers. Outlier means the exact respondent whose response is creating great disturbance. You need to delete that row in SPSS. That means you are deleting a particular respondent from your sample size. You are deleting a particular respondent from your sample size. That means one row from the particular SPSS file. Now you will ask, sir, how to test the outlier. There are outlier options. Do not worry. There are outlier options in the SPSS. You can do that. Clear?
Okay, sir, it means you may, if I got it, you mean to say that either we can increase the size of our sample or we can delete some of the respondents after finding out them as outliners. I mean, we have to identify outliers. Yes, sir.
These are initial two. So many things are there. The third thing is you re-specify your model. Suppose I have specified BSI 1 to BSI 5 under F1. Suppose by chance BSI 3 is creating the disturbance and it should more likely to come to F2 or F3. You re-specify. There is a chance that the Horman's one factor score will be lesser. You re-specify.
No, sir, but if there is altogether like 21, 22, items are there in one questionnaire, if I'm taking like as you took 21, 22 questionnaires, among that we found only one after running the Hammond's rule. So that is only one that comes to somewhere around above 50%, let's say. So
see, madam, I think you are confusing. Madam, you will not report the result of one factor in your thesis. Simply you write by Horman's one factor score, the cumulative variance is less than 50%. So common method biasness is not existing. You need not to report the result of. Please listen carefully. You need not to report the result of one factor. I think you are thinking that the result of one factor will be taken instead of 5. No, you will take those 5 for your consideration. For the sake of testing, jabardasti you are specifying one. Whether your factor is explaining more than 50%, if it will be taken one, if you need not to take that one instead of 5 in my research. In my research, the 5 construct I will take. I will not take one at all. I will take 5. Just to test Horman's single factor theory, I have taken specified one. Only you write 2-3 sentences in your thesis or article that by testing Horman's single factor score, the cumulative variance is coming out 38% near about, which is much lesser than 50%. So there is no threat of common method biasness. This much you will write.
Okay, sir. Okay.
Nothing else. And if you want to explain in your thesis something more, you need to write, by testing Horman single factor theory, I have made it unrotated. I have specified one factor only, and cumulative variance is nearly 38%, which is much lesser than 50%. So there is no threat of common method biasness. Somebody is asking something.
Yes, sir. Sir,
Okay,
suppose,
sir. Fine.
suppose,
Perfect.
suppose,
Thank
sir,
you, sir.
because of one factor, it is more than 50%, and then doing the trial and error method, for another factor, it has become less than 50%. And also we can interpret it like that, sir.
Sir, the same data set, when how many times you will do by it, specifying one, it will show the same result. How come you are saying trial and error? You are saying trial and error to the same data set or different data set?
Same data
So
set,
you
sir.
mean it is showing since it is showing the cumulative variance for all the factors together. So no matter how many times we do, there would be only one figure that is cumulative of all.
No, sir is saying trial and error.
Okay.
Sir, you are specifying one factor in your SPSS.
Yeah.
आप हजार बार कीजिए वही प्रोसेस को. Please listen.
We do not specify.
Please listen. I got your question. I think you are saying the more times you are specifying one, it will give different result. No, same data set. You do 1000 times specifying one factor, the same result. Same result
Sir,
you will get. There is no question of trial and error.
I got it, sir. Sir, I thought first, suppose I select BSI1 instead of selecting BSI1. Can I select BSI2? That was my.
Please, I think you are thinking that only BSI1 I am taking. No. No. That BSI1 is an indicator.
Okay, got it, sir.
BSI1 is an indicator. Sir, listen. Till now, you are confusing the indicator with factor. BSI1 is an indicator. I am talking about one factor or one construct. Got it?
Yeah, got it, sir. Yes, sir.
Okay. So there is another. Suppose somebody will ask, sir, why I should go to the SPSS? Why not in the AMOS? Why not in the AMOS? There will be a test. Why not in the AMOS? There will be a test. Yes, there is a test in the AMOS, which is little bit lengthy, but it is giving more confirmatory result. All of you have the patience. All of you have the patience to see. All of you have the patience to see.
Yes, sir.
What some researchers are saying, what you need to do, you relate all the indicators to a common factor, because single factor, relate all the indicators to a common factor. Now I have made a common factor. My AMOS screen is visible to all? Visible to all?
Yes, sir.
Now you create a single common factor and relate everything here. Relate everything here. Relate. This is a very good test, and it is giving more confirmatory result regarding CMB. It is giving more accurate result regarding CMB. Relate every indicator to a single factor or single construct. Instead of 5 construct, you relate everything to a single construct. Relate everything. It will take some time. If you have the patience, then I will say. Otherwise, it is creating a problem. Relate every construct. Relate every construct. Relate every construct. If you are doing, all of you please do it. If you are doing it, you can do it. Relate every construct to a single separate construct. Relate it. It is because I am doing CMB, I do not require the second order construct. So let me delete it. Then what I will do, I will select this in order to covariate. If I delete the second order, I need to delete these also. अगर second order को delete करना है, इसको भी delete करना है. Then what I need to do, I need to covariate as usual. I need to covariate as usual. I need to covariate as usual. Now covariate, the covariate, covariate. Where is that covariate? Where is that covariate? Draw the covariance. Covariance done. Now what I need to do is now on select. What I need to do is take it parameter constraint. See, take the drag property. I'm showing you again. Take the drag property, then tick on the parameter constraint. Tick on the parameter constraint.
Where you have taken drag properties?
Look at here. Look at my cursor movement. Look at my cursor movement. Look at this is drag property.
Sir, seen.
Then check the drag parameter constraint. Done it, madam? Done it?
Yes, sir.
Then close it. What I need to do, I need to constrain to the same. Click in any of the relationship that you have made just now. Give any regression weight A, B, or C. Any? I am taking A. I am taking A. See, it is shown as A. It is A. Let me highlight that to some extent. 18. Let me take A. What I will do is, I have already checked the parameter constraint. So what I will do now, I will drag and drop. How I will drag and drop? If you can manually do it for everyone, it is okay. But it is very impossible to manually do. It will take half an hour. So what I will do, I will select everything. select. I will select everything. First, select everything. Select. Then I will simply drag and drop. So select everything. Select. What is this? Select. What is happening? Select. Is there any black arrow mark? Select.
DSI 11, sir.
Select. Still, is there any black arrow mark? See this?
Yes, sir. One, I think I can. Yes.
Now,
last one.
Now every arrow mark has been blue. Now what you need to do, take from here and drop anywhere. Sorry, what is that? Select. So I need to uncheck it. I need to take the drop. अरे क्या हो रहा है ये? Drag and drop. Drag and drop. Sorry. Drag and drop. Sorry. What is happening? Now every variable has been constant by A. Now every variable has been constant by A. Are you
Yes,
all
sir.
following me or not?
Yes, sir. Yes, sir.
Yes, sir.
Every variable has been constant by A. So this is the step. Next step. What is the next step? Next step is I need to constraint it by 1. This latent variable I need to constraint it by 1. So latent variable ko 1 kar do, because it is a single factor. What is happening here? Hmm? What is happening? Hmm? Oh, sorry. I need to name it first. I need to name it. As because I have not named it, it is not showing anything. So name it common factor. Common factor. Common factor. Common factor. One. Reduce it. Reduce it. Sorry, what is happening? Reduce it. Common factor. Name it. Then I need to constant it to 1. Sorry, still it is not showing 1. I do not find why. Set by default. Done. I need to constant it 1. I cannot. What is happening? Somehow this is not showing. Okay, let me deselect. Let us see. Deselect. I think now it will show. No, still not showing. This need to be constant by 1. This need to be constant by 1. What is happening? I do not find.
Variable level.
No, that will not create any problem.
Okay, sir.
That will not create any problem. Let us say again. It should be this particular thing need to be constant by 1. Why is that not happening? Let us analyze. Proceed with analysis. Proceed. The variable name common factor is invalid because it contains an invalid character. What is this invalid character? What is this invalid character? I am not getting. Which is common?
The space.
Proceed with analysis. Is invalid because it contains an invalid character. What is this? I do not know. What is this invalid character?
So there is space between the two words.
Maybe space, sir. In means you wrote there common then factor. In between common and factor,
So there's a space.
there is a space. So we can verify by reducing the space.
But this need to be constant by 1. I do not know why this parameter value is not appearing. See, what is happening? Okay, this parameter need to be constant as 1. This common factor need to be constant as 1. Then you need to calculate. Please see the you need to calculate and you need to proceed. No need to worry. You need to proceed with analysis. After proceeding with analysis, the same value will appear here. If you click here, the same value will appear instead of A. And if this value is not more than 30, 40% or 30%, then there is a less threat of common method variance. Okay. If this value will appear more than 0.3 or 0.4, there is a threat of common method biasness. Somehow it is creating a problem. Sometimes this SPS, this AMOS is creating a problem. I do not find what is happening. So this need to be constant as 1. This particular latent variable that I have created just now, this need to be constant as 1. I do not find why it is not happening as 1. Anyway, so all the after you analyze, you click on the upward red highlighted arrow mark, and you will find in place of A some values. 0.1, 0.2, 0.1, 0.2, 0.001, 0.003 you will get. But whatever you will get, the same value you will get. If the value is not more than, if the values are not more than 0.3 or 0.4, let us say 0.3, then you are safe. If the values are not more than 0.3 or right now it is taken as 0.4, then you are safe. If the values are less than 40%, then you are safe. All of you get my point? All of you are clear?
Yes, sir.
Yes, sir.
So this is another way of testing the common method biasness. One simplest way is Herman's one factor theory. Herman's one factor theory or Herman's one factor testing. And second, in the AMOS you will test like this. So so many other things are there. Because of the time I could not proceed. Now the platform is open for the participant. They can ask some one or two doubt. Thereby we will proceed for the next session tomorrow, which is most important, SCM and fit indices. All the fit indices which are important you will report in your thesis or article. We will discuss today, tomorrow. The fit indices, I think today is this much from my side. And over to the participant. If anybody has a doubt, I can address those questions.
Sir, I have a question. Like, if we are having 4 or 5 scales in our study, so one by one we have to check CMB, or we can do collectively also?
No, madam, whatever I'm asking, you go on saying yes or no. I understand your question. You have more than one scale in your questionnaire. Is that right?
Yes. Yes, sir.
Whether all the scales along with all the variables you will take to a single CFA?
Yes, sir. If
then there will be a problem.
Okay.
If you are creating one CFA with one scale, another CFA with other scale, then it is okay, nothing wrong.
Okay.
Nothing wrong. Even if, madam, listen, even if it's the same research work, but two different CFA and the scales are different for two different CFA, then it is okay. If you are taking all the different scales of items to a single CFA, it will create a problem. Why? Suppose you are taking 5-point Likert scale 1 to 5. Suppose BSI 1 I will take 1 to 5, BSI 2 I will take 7-point Likert scale 1 to 7, BSI 3 I will take 9-point Likert scale 1.9, 1 to 9. Then how come the error will be decided? Obviously error will be more in 5-point Likert scale than the 7-point Likert scale than the 9-point Likert scale. In the 9-point Likert scale, error will be lesser. Clear?
Okay, fine, sir. Fine.
This is one. What is next? Suppose you are adopting 5 Likert scale, any point Likert scale for BSI 1, but semantic differential scale for BSI 2, ranking scale for BSI 3. How come the reflection of a single factor will be done? Please understand the logic. A single construct you are reflecting. A single construct will be reflected in different measurement. Then obviously there is a common method biasness because the method inherent difference. Clear?
Okay.
So if you are taking different CFA, different measurement scale, it is okay. No problem.
Okay, sir. Thank you so much.
Any other question? I think this much is okay. So tomorrow we will see the same time. The last thing, that is structural equation modeling, that is path analysis, and the most important is the fit indices by which you will say your model is fitting to the data. This part we will discuss tomorrow. So over to the organizer.
Thank you very much, sir.
Thank you, sir. Thank you.
Thank you. Over to the organizer. Varda sir.
Thank you, sir.
Thank you. Thanks a lot. All of you,
tomorrow we will have the
tell me.
Tomorrow we will have the same time, 4 to 6.
So my sincere request to all of you, please practice in your home. Please practice in your home and come tomorrow so that you can ask your difficulty. So for today is all okay. Thank you all. Thank you all.
Thank you very much, sir. Thank you.
Thank you, sir.
Thank you all of you. Thank you very much.
Thank you, sir.
Shall we leave, sir?